dear viewers, in this video lecture on number system. The first question that we must ask ourselves is why we require numbers. The first reason is that we need to measure and express the magnitude of different physical quantities. The second reason may be that we need to quantify different day-to-day things in life. For example, 1 dozen of oranges, and we know it is equal to 12 oranges. Another example may be that there are 6 balls in 1 over in cricket game. Another example may be that a student have got 80 marks out of 100 in maths paper. Furthermore, we can say we require number system for counting purpose. So in a nutshell, we can say number systems is the language to express calculations or measurements of the physical quantities. The favorable thing for us is that out of different number systems, we already know and are able to comprehend decimal number system. I would like to take an example of a decimal number to refresh our childhood memories, and this example will help us in upcoming discussion. Consider the decimal number 512.7976. So 512 is the integer part, and this is the fractional part, and this we call as radix point. This number can be expressed as 500 plus 10 plus 2 plus 0.9 plus 0.07 plus 0.006. When we add these numbers, it will get into 512.976. We can further simplify this as 5 multiplied by 10 raised power 2 plus 1 multiplied by 10 raised power 1 plus 2 multiplied by 10 raised power 0 plus 9 multiplied by 10 raised power minus 1 plus 7 multiplied by 10 raised power minus 2 plus 6 multiplied by 10 raised power minus 3. You see what is happening here is that this 2 is located at the ones place and it gets multiplied by 10 raised power 0, which is equal to 1. So its weight here is at the ones place. The 1 is at the tens place, that is why it is multiplied by the 10, and the weight of 5 is 2 because it is multiplied by 10 raised power 2, that is it is at the hundredth place. Similarly, 9 is at minus 1th place, 7 is at minus 2nd place, and 6 is at minus 3rd place in the decimal number system. So we will use this explanation in a general number system theory. If we talk about number system in general, every number system is characterized by radix R, or we can say base B. A number system with base B will have B number of different symbols, which are weighted from 0 to B minus 1, and the number is represented as n in the brackets with the subscript B. Let me take certain examples. Let us suppose we have a number system with base 2, then the symbols will be 0 to 2 minus 1, that is 0 and 1. If the base is 8, then the symbols will be 0, 1, 2, 3, all the way up to 7. For base 10, we will have symbols from 0 to 9. For base 16, we have weights from 0 to 15, wherein weight 10 is represented by A, 11 is represented by B, 12 is represented by C, 13 is represented by D, 14 is represented by E, and 15 is represented by the symbol F. Similarly, we can have any base and symbols will be always weighted from 0 to B minus 1. Now the question arises, can R be 0 or 1? You can post your comments in the comment section. Let us do a simple exercise what we have learned so far. Which of the following numbers in their respective number system is correctly written? You can easily conclude that first and fourth are the correct options and second and third are not correct options, because if 3 is the base, 3 cannot be the symbol. If 5 is the base, 5 cannot be the symbol, because the weight of the symbol is always 0 to B minus 1. So in general, any number can be represented by an integer part of n digits and fractional part of m digits, where d represents digit or symbol and subscript of d represents weight of that symbol in that particular number system. As we have already discussed it as an example of decimal number 512.976. So each symbol and its weight can be represented as 5, 1, 12. This is the base weight 0, weight 1, weight 2, weight -1, weight -2, and weight -3. So this is the respective weight of each symbol. That is all for this video. Thank you.